Lesson 9, the power to choose. Now that students can go back and forth between fractions, decimals, and percentages easily, let's go ahead and talk about why it's powerful to do so. In part 1, we're going to convert percentages to decimals and fractions. So here we have the percentage 25%, and as a decimal, that's written as 0.25 or 25 hundredths. Now let's write it as a fraction. 25 hundredths is written as 25 hundredths. Simplify it, and we have 1/4 as our answer. Next up, we have 50%. Here's 50%. As a decimal, it's 0.5 or 5/10. Remember, we're going to leave out that trailing zero. And as a fraction, 5/10 is written as 5/10. Now all we have to do is simplify this. So divide by 5, divide by 5, and our fraction is 1/2. Next step. Here's 75%. As a decimal, it's 0.75 or 75 hundredths. As a fraction, that's written as 75 hundredths. Let's go ahead and simplify. Divide by 25, divide by 25, and that gives you 3/4 as our answer. Now part 2 will show students how powerful it is to be able to switch back and forth between the different forms of these numbers. Part 2 reads, solve. Complete all of column 1 first, then complete all of column 2. And in column 1, we're going to be solving with decimals. So let's take care of column 1 first. Here it says find 20% of 25, find 50% of 18, find 25% of 16, and find 75% of 32. So let me go ahead and convert all these percentages to decimals first. I know that 20% is 0.2 or 2/10. 50% is 0.5 or 5/10. 25% is 0.25 or 25 hundredths. And finally, 75% is 0.75 or 75 hundredths. And now we're going to set these up as multiplication problems. So for the first one, we'll do 25 times 2/10. And when I set it up, I'm actually going to leave out the leading zero so that my work looks cleaner. So I'll write down 25 times 2/10. And I made sure that I made my decimal point nice and clear. 5 times 2 is 10. 2 times 2 is 4, plus 1 gives you 5. Move the decimal point over, and our answer is 5. Next one. 18 times 5/10. 18 times 5/10. Here's 40. 5 times 1 is 5, plus 4 gives you 9. Take care of your decimal point, and our answer is 9. Now we're going to see it get a little more complicated because we have double-digit multiplication. Next we have 16 times 25 hundredths. Here's 16 times 25 hundredths. 6 times 5 is 30. 5 times 1 is 5, plus 3 gives you 8. Here's your placeholder. 6 times 2 is 12. 2 times 1 is 2, plus 1 gives you 3. Now we add them together. Move your decimal point over the correct number of places. 1, 2. And our answer here is 4. Here's the last one. 32 times 75 hundredths. So we'll write down 32 times 75 hundredths. 2 times 5 is 10. 3 times 5 is 15 plus 1 gives you 16. Here's your placeholder. 2 times 7 is 14. 7 times 3 is 21, plus 1 gives you 22. Add them all together. 2, 3, 4. Here's a 2. 1, 2 decimal places. 1, 2 decimal places. And our answer is 24. And this is what you want to point out to students. The first two problems weren't too bad, but when we got to these multi-digit multiplication problems, it involved doing a lot of work and a lot of calculations. So now let's see how using conversions can help us save a lot of work. So here's column 2. We're going to work on the same problems, except this time we're going to use fractions instead of decimals. So let's take a look at the problems and figure out what the corresponding fractions are for these percentages. So 20%, instead of writing it as 2/10 as a decimal, I'll write it as a fraction. And students can work it out. And if they've memorized that 20% is 1/5, that's even better. So this fraction here is 1/5. 50%, that's an easy fraction to figure out. That's 1/2. Here, 25% is 1/4. Next, 75% is 3/4. So I'll write that down. Now let's go ahead and work these out using fractions instead of decimals. So instead of writing 25 times 2/10, we'll do 25 times 1/5. So here we have 25 times 1/5. Before we multiply, let's see if we can simplify anything. And we can simplify the 25 and 5. So divide by 5, divide by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. 5 times 1 gives me 5. And you'll notice it's the exact same answer that we got when we used decimals. And it was about the same amount of work. Let's go on to the next one. Instead of 18 times 5/10, let's do 18 times 1/2. Here's 18 times 1/2. What can we simplify? We can divide by 2 and divide by 2. This will give us 1, and this gives us 9. 9 times 1 gives us 9. And again, you'll notice it's the same answer that we got when we used decimals. And it was about the same amount of work. Now here's where it gets interesting. For the third problem, instead of 16 times 25 hundredths, we'll do 16 times 1/4. Here's 16 times 1/4. Let's simplify first. We can divide by 4 and divide by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. 4 times 1 gives you 4. And once again, you'll notice, same answer that we got when we used decimals, but this time, this was a whole lot less work than using decimals. So in this situation, I'd rather use a fraction instead of a decimal because I can get the same answer a lot faster. Here's the last example. Instead of 32 times 75 hundredths, we'll do 32 times 3/4. Here is 32 times 3/4. What can we simplify? We can divide by 4 and divide by 4. This gives us 1. And here we have 8. 8 times 3 gives you 24. Once again, we got the same answer, but with a whole lot less work. And that's the power behind conversions. When you can convert numbers into different forms easily, it opens up choices. So here, in these first two examples, they were about the same amount of work, but when I got to the last two examples, it was a lot easier to solve them as fraction problems rather than as decimal problems. So in these two examples, I would much rather use a fraction than use a decimal. And in order to do so, we need to be able to easily move from fractions to percentages to decimals. And that's what conversions are all about. Let's take a look at the last line, which I've completed. And it says, the ability to convert gives you the power to choose the easiest method.